Utsab, and I take this opportunity to introduce myself and my team on our deep learning project that we undertook as part of our virtual internship with Bennett University. This internship is organized in collaboration with Leadingindia.ai. Firstly, I would like to extend my gratitude to the Bennett team for accommodating to this difficult situation and organizing this remote internship, which not only benefits people from around the university, but across the country. We in itself, in our team, have had members from all corners of India, and the opportunity we got to interact, learn, and share our ideas with each other was really a great experience for us. The title for our project is Classification of IoT Network Traffic by Applying Deep Learning Techniques. Over the last 6 weeks, we have been working under the able guidance of Mr. Rakesh Kumar. Our team in itself includes Gauri Shankar S. and Julianne Elsa Thomas, who are from Kerala, Sachin Bhatia from Mumbai, and myself from New Delhi. It won't be surprising to me if I asked you guys what you mean by the Internet of Things and you having a fair idea about it. One of the greatest inventions in the globalized era has been of the Internet. It has really connected the whole world together. Extending the current Internet with interconnected physical devices or objects, or we can call them things, is what constitutes the Internet of Things. There are already about 22 billion IoT devices in use until 2018, and it is expected to reach 50 billion by 2030. With such density of device in operation and them being continuously increasing, the network traffic and movement of signals through the network is getting more complex by the day. This is a huge problem for network operators. Moreover, the characteristics shared by the IoT devices makes them harder to segregate and classify. This was a primary motivation for undertaking the project and trying to find a unique deep learning based approach for device classification. As we go through what we covered in our projects, you will see one or more of our team members explaining the key concepts and ideologies we used in our studies. Over to you guys.
As mentioned before, our project is titled Classification of IoT Network Traffic Using Deep Learning Techniques. The usage of IoT devices have increased exponentially over the years. The critical problem this poses is that it can be difficult for the operators in a smart environment to determine which of the IoT devices are connected to the network and which of them are functioning properly. Therefore, it is paramount to acquire visibility into the IoT devices. We addressed this problem by developing a device classification architecture that can detect and classify IoT devices. In order to achieve this, we prepared our dataset using the characteristics of network traffic that we have collected over a period spanning 20 days, almost 3 weeks. The testbed consists of 28 different IoT devices, including sensors, cameras, and other appliances. The first step is to uniquely identify and separate each of these IoT devices from the rest. We used the MAC addresses of each of the devices to do this. We developed a Python script using Scapy to automate the storing of the features of each of the IoT devices as separate PCAP files so that the IoT devices can be distinguished. Most of the internet traffic was transmitted via the TCP protocol and the rest through the UDP protocol. We developed a Python code to analyze the network traces and extract TCP and UDP flows. We created sessions which were then used to construct flows. All of this was stored as CSV files which were then used as the input to our deep learning classifier. The architecture that we used was a variant of RNN recurrent neural network called LSTM, long short-term memory.
Security on IoT devices has been a constant problem for various network operators, and accurately identifying the IoT device will help to devise various security solutions for these IoT devices. Our model is based on time series classification. Over the years, time series classification has been very challenging because of huge data, high dimensionality, and constantly updating data. But with the advent of deep learning, new methods have been developed, especially convolutional neural networks and long short-term memory neural networks. For our classification, we have trained a LSTM neural network Our data is highly categorical, so the loss function used both categorical cross entropy with Adam optimizer and sigmoid activation function. We achieved an accuracy of approximately 93%.